Welcome to Science in 5. In this video, we're going to discuss position. Well, position is simply the location of an object measured from a reference point. Now, another word for reference point simply means a 0 point. Where do you start doing the measurement? So, position needs two things. Okay? Position needs a reference point, and you need a distance from that reference point, right? And then you also need to give the direction from the reference point. Okay, so that's how position works. Okay, most reference systems are grid systems. Okay, and the most basic of a grid system that we normally use is a two-dimensional reference system, such as a Cartesian plane or longitude and latitude lines, or even the geographer's cardinal points. The cardinal points are similar to a Cartesian plane. But in science, we tend to focus on a system that is very similar to the Cartesian plane. Sometimes we modify it, okay? Sometimes we change it. So here's a two-grid system, or a two-dimensional grid system. We have got measurement along the horizontal, along the X, and measurements are made along the vertical or along the Y. Okay? The 0 point is where these two lines intersect. We call that the origin. And the location of that is given this point 0, 0. Okay. Now, suppose we have a point A and a point B there, and these points are located at these given points on the Cartesian plane, like that. Starting with A, what will be the coordinates of A, or what is the location of A? When you use a Cartesian plane, we use what is called a coordinate system, XY coordinate system. You give the X value, and then you give the Y value. It's a way of trying to reference where A is located on this grid. Okay, that's how we do it in maths. In science, we slightly modify that, and instead of using the negative and the positive, we turn that into a direction. So let's see. For example, A is going to be minus 15, minus 2. So which means along the X, it's minus 15. Along the Y, it's negative 2. B, what do you think the coordinates of B would be? You read the X value first, and then you read the Y value. So the X value there is 10, positive 10, and the Y value there is negative 8. So the coordinates of B are 10 and negative 8. Okay, but in science, we want you not to write negative numbers like this. We want you to change those negative numbers into a direction. How does that work? Well, I can say the positive y-axis is the same as the north. The positive x-axis is the east. Opposite the north is the south. Opposite the east is the west. Okay, so if I move from the origin and I move in that direction, I'm going towards the west. If I move and I go in that direction, I'm going in the east. If I move that direction, I'm going in the north. If I move in that direction, I'm going to the south. Okay? So using that idea, we can say the north is actually positive, the south is negative, the east is positive, and the west is negative. So now let's try and give the location of point A again using east, west, or north and south. We can now say that point A is 15 units in which direction? In the west direction, and 2 units in which direction? In the south direction. So it's 15 meters going west, and then going along the vertical, you need to go 2 meters south. Okay, so in science, this is the more acceptable way of giving location. Okay, give the magnitude and the direction. Okay, so here we have assuming that these distances are in meters. Okay, let's just add that there. That's meters. and this is also in meters. Okay. Similarly, the coordinates of B would be 10 meters east and 8 meters south. Like that. Okay, not so difficult. So when you give position, we change the positive and the negative into east. Remember, the east is always opposite the west, or the positive always opposite the negative in terms of direction. Okay, that's how you'd give the position. Now, we've got this simple activity. It says use the grids system provided, give the position of A. So according to this system, this is the 0 point. So A is in the eastern direction. There are no units of measurement. So A is 1 unit east. I know some will say, but what if I just say positive 1? I would rather you write it like this: distance and direction. D, you can see that it's -4, but -4 is the same as 4 units west of the reference point. So that is the position of D. Using C as a reference, give the position of, so if C is the reference means it's the 0 point. So this is where 0 is, right? So what is the position of B? So how many meters do I need to travel from C to B like that? Okay, so you can see that I'll travel 4 minus 2. So this distance is actually 6, because I will go 1, 2, 3, 4, 5, 6. Okay, so B is actually 6 units east. Okay, what about D? D, I have to go in the western direction now to get to D. And how many units do I move? 1, 2. So D is 2 units west. Okay. An object travels 7 meters from C and then another 6 meters west. What is the final position of the object? So, okay. So we are making an assumption that, again, this is in meters. Fine, not a problem. So which means this answer is always, we're going to change these answers. Instead of saying units, we can just add meters there. Okay. So that's 1 meter, 4 meters, 6 meters, 2 meters. Okay. All right. So we move 7 meters east and then 6 meters west. Now remember, moving in the east is the positive direction and moving there is the negative direction. So 7 meters east is the same as a positive 7 plus 6 meters west is the same as a negative 6. What's 7 plus negative 6? This is the same as 7 minus 6. This is a positive 1. So the final position of this object is simply moving 1 unit forward. So this would be 1 meter east. Or you can do it step by step. Again, you can move the 7 meters and then come back. You can go 1, 2, 3, 4, 5, 6, 7. You're there. Now you need to come back 6. 1, 2, 3, 4, 5, 6. You land right there. Okay. So basically, you moved that much. And then you came back that much. And then this is, you came back not that much, you came back all the way You came back all the way to this point here. Okay, so you moved 7 meters, then you move 6 meters back. So your final location is 1 meter east. Okay, so position, to give position, distance and direction from a reference point, we normally use the 2-grid system, but for now we're taking the simple approach where we look at more of position in the 1-dimension scenario. Okay, and later on we'll do the position in 2-dimension. Okay guys, that's how you give position. First, secure the reference point, that is the 0 point where you start doing your measurements. Use the simple system where you say moving east is positive, moving west is negative, or moving north is positive and moving south is positive. Okay guys, thanks for watching. I'll see you in the next video when we start talking something more about displacement. What is displacement in relation to position? Thanks for watching guys. See you guys next time. Ciao, ciao.